Welcome to B.TECH, my dear students. In this video, we are going to learn about process control block, which is in short form termed as PCB, which maintains all the states and records and activities of particular process from it is moved from the secondary storage to the primary memory, and from the primary memory to the execution, and in the execution also there are different stages, and those records and complete details are maintained and controlled by the process control block. It is maintained by the operating system to know the activities of process. Here you can see operating system manages and controls resources, that means controls the resources by having a table. Here the tables are implemented as the data structures to store the information about every process and resource. That means what are the resources allocated to the process and what are the process that are there for execution. This is the reason operating system maintains the memory table and input output table and process table. Here you can see process table stores ID, that is information data of every process, and corresponding to it the pointer to its PCB. That means first it maintains every process ID, and along with that it maintains a pointer to its program, that means process control block. Here the stages are there for a process. They are running state, ready state, blocked state and suspend state. To maintain all these data, a program counter is there, that is process control block is there, which is pointed. That means all these are pointed to the process control block. And next one is, what is a process control block? Here we are going to learn a process control block is a data structure maintained by the operating system for every process, and that means it is different from process to process. That means when process is came from the new state, that means a process is created and it is moved to the ready state. From that time to the termination time, a new PCB is maintained for each process by the operating system. Some operating system maintain only PCB, and in that PCB has all entries stored by the process table. And here you can see a process control block is also called task control block. That means the task is nothing but a process. Here what a PCB, that is process control block, maintains, it maintains the process ID, that means to identify the process, the state of process, pointer which points to the next instruction, priority of the process, program counter which tells what is the next instruction that has to be executed in the processor, and CPU register which maintains the data, and input output info. Input output info means the resources, that means input resources, output resources and IO operations. About IO operations and all these are maintained here. So process control block maintains different information about the process and about the resources. Here you can see the first one is process state, the current state of process, that means at present state in what position a process is. Suppose it might be in the ready state, or it is in the running state, or in the waiting state. Coming to the process privileges, that means allow, disallow the access to the system resources. Next one is process ID, unique identification for each process in the operating system. Next one is a pointer. Here a pointer is the thing which points to the parent process. Why we are calling specifically the parent process? We are going to learn about this parent process, where if I am terming it as the parent process means there is another process termed as child process. So we are going to learn about these two also. Program counter. Program counter is a pointer to the address of next instruction that has to be executed in the next step. That means a process is set of or collection of instructions. Here these instructions these instructions need to be executed in step by step. So, in the step by step execution of instructions, the program counter need to point which instruction has to be executed in the next step. That means in the next state. So, program counter maintains the record of sequence of instructions that need to be sent for next execution. Next one is CPU register. Various CPU registers where the process need to be stored and for execution of or for the running of state. Here the registers are maintained to store the process and to perform the execution and to maintain the running state. So, for this the CPU registers are there. Next one is CPU scheduling information. That means what is the scheduling criteria or architecture that is applied onto the processes. This information includes process priority, pointers to the scheduling queues, and if any other scheduling parameters are there, those are maintained in the scheduling information. Next one is memory management information, information of page table. Here the page table maintains the memory allocation of different processes. Those are maintained in the table called page table. And memory limit, that means which amount of memory or what amount of memory need to be allocated for particular process, and segment table information. So, these are maintained in the memory management information at PCB. Next one is accounting information. It includes the amount of CPU used for process execution. That means for particular process, what amount of time at CPU for execution is required or used, and the time limits as per the scheduling criteria. That means suppose there are different scheduling criteria that are applied on to number of processes. There is a time limit while coming to different scheduling algorithms. The time limits also need to be maintained. So, if time limits are not maintained, then the process need to in the waiting state for number of, that means huge amount of time. Next one is execution ID, that means unique identification for execution. Next one is input output status information. This includes the list of input devices and output devices, and those are allocated to the process. That means suppose for some particular process is there, like P1 is a process and it allocated some input devices and it allocated some output devices. Their information is maintained here, that means to that particular process. Here PCB maintained for a process throughout its lifetime. Here what is the lifetime of a process is nothing but from the new state to the termination state is called the lifetime of a process, and it is deleted once the process is terminated. That means the data that which is there about a process in PCB is deleted. That means the information in the PCB of particular process is deleted once the process completes its execution. Here you can have some more extra information in the picture, that is about PCB. Here you can see PCB counter, which gives next process PCB process state. That means there may be different states: ready, run and wait. Process number, which is nothing but what we defined as unique identification number of a process. Program counter, parts of program or process belongs to, that means parts of program nothing but instructions. Here register, these registers are used for storing the different data about the process as well as the output, and moreover these registers are used for the execution, these registers are used for the storage, and these registers are used for generating the result also. Next one is memory limit, base limit, and these include start and end. Base and limit means starting and ending. Next one is accounting info, that includes different information about the process. So my dear students, this is about PCB, that is process control block. Thank you so much. We are going to continue in the next session.